Okay guys, so now it's time for math, but before we begin in the book, I want you to get out today's packet. There's only one thing in it, and it is today's anchor chart. So make sure you have that out. Remember, you're keeping that. Do not turn it into me. So all you have to do is you can tear off this front page, put it in the recycle bin, and then keep the anchor chart. So we're going to look at that first, and I've got it on the board. Today we're learning about units of customary weight. So we've talked about units of length, of customary length, customary capacity, and now we're talking about customary weight. So this is what we use most commonly here in America. So from lightest to heaviest, which is synonyms for least to greatest or smallest to largest, we have ounces. Now these are not fluid ounces. They are not the same as fluid ounces. Fluid ounces are a unit of customary capacity. Ounces are units of customary weight. 1 fluid ounce does not necessarily weigh the same as, does not necessarily weigh 1 ounce. They don't really have much to do with each other than they both are the smallest units of their respective types. Ounces are the smallest unit of customary weight. Fluid ounces are the smallest unit of customary capacity. So you do abbreviate ounces the same way in fluid ounces and regular ounces as OZ. To imagine, 1 ounce is about the same as a slice of bread. So if you hold a slice of bread, excuse me, it is about 1 ounce. Then we have the next lightest, which it's right in the middle, we have pounds, which is abbreviated as LB. I don't know where that came from, but pounds is abbreviated as LB. I think it's because in another language, pounds has LB in it. And it's about the weight of a loaf of bread. So if you take the whole brand new loaf, that's about a pound, give or take. Then we move to the heaviest, which is a ton. Now, this is where you need to pay attention. Tons are abbreviated as a capital T. So up until now, everything's been lowercase. Well, tons is abbreviated with a capital T because a lowercase t means something else. So when you are abbreviating tons, make sure you use a capital T, not a lowercase t. The word tons does not need to be capitalized. It's just that they had to use a capital T for the abbreviation because a lowercase t already meant something else. I think it means time. So they use capital T to say they're talking about tons, not time. A ton is about the weight of 1 elephant. So 1 elephant weighs about 1 ton. Now yes, there is a very big difference between 1 pound and 1 ton, but that's just how it works here. So we have ounces, which are the smallest, pounds, which are right in the middle, and then tons, which are the largest. Okay, so now that we've talked about that, let's go ahead and move on to the book. Oh, just as a reminder, remember, whenever you're converting, you need to be able to look at this chart and say, okay, well on the left is the lightest unit, and on the right is the heaviest, because when you're converting, you need to figure out, okay, do I know the lighter one? So I know the small, and I'm trying to find the bigger one, so small to big, which means I divide. Or do I know the larger one, and I'm trying to get the smaller one, which means I'm going from big to small, which means I multiply. Also, if you're trying to go from ounces to tons, don't forget you need to go to pounds first. Same if you're trying to go from tons to ounces, again, you have to stop at pounds. So this chart is very important when we're doing conversions, just so that you know which ones are lighter and which ones are heavier, and if you have to add an extra step in between. Okay, so now let's go ahead and move on to the textbook. We're on page 723. Okay, so you should be open to page 723. You can still have your chart out, your anchor chart out, so that you can look at it when you need to. But let's go ahead and read the sentences under the title together. The weight of an object is how heavy it is. We learned that in science. Well, now that's something important for this chapter of math. We know the weight of an object is how heavy it is. The customary units of weight are ounce or OZ, pound or LB, and ton or capital T. Here's where you can see that the word ton does not need to be capitalized, but the abbreviation does. And that again is not because it's proper or common, it's just to show that we are talking about tons and not what the abbreviation for a lowercase t is, which I think is time. And here we have another chart giving us examples. So 1 ounce is also about the weight of 1 strawberry. 1 pound is also about the weight of probably a smaller pineapple. And 1 ton is also about the weight of a small car. Not a big SUV or a big van or even a big car, but a small car weighs about 1 ton. A bigger car weighs more. Like maybe a bigger car weighs almost 2 tons, and vans and SUVs weigh even more than that. So a strawberry and a slice of bread are about 1 ounce. A pineapple and a whole loaf of bread are about 1 pound. And an elephant or a smaller car are about 1 ton. Okay, so let's move on to the examples. Okay, so this lesson is more introducing the units of customary capacity. So again, we're not going to be doing any conversions today. We are just going to be doing some estimating and some choosing the correct capacity. So everybody, finger or pencil on example 1, and read in your head while I read out loud. Susie's father bought some sugar for their favorite recipe. Which is a more reasonable unit to use for the weight of a bag of sugar? Ounces or pounds? So what I want you to do right now is imagine a bag of sugar. If you know your parents have a bag of sugar, and as long as it is mostly full, you can grab it and you can hold it and you can feel it. Let's read this sentence. So, as you're imagining or actually holding that bag of sugar, think of a small packet of sugar. So one of those ones that you see at like restaurants on the table. They have those small little packets of sugar. They're like a little rectangle, and they have about 1 maybe teaspoon of sugar in them. A small packet of sugar would be weighed in ounces. It's very small. So we would weigh it as ounces. A bag of sugar is much larger and would be weighed in pounds. A bag of sugar is kind of heavy, at least when it's brand new. If you have like an almost empty bag of sugar, it's not very heavy. But a brand new bag of sugar is pretty heavy. A packet of sugar is very, very light. So the packet, we would use ounces, but the bag of sugar, I have them opposite, sorry. The packet is very light, so it'd be up here. And the bag is very heavy if we had a balanced scale. So that means that pounds is a reasonable unit to use for the weight of a bag of sugar. In fact, if you go to the grocery store and buy your bags of sugar, you're probably most likely to buy a 5-pound bag. You know it's, oh no, you don't have the same one, but it's kind of funny because this bag is definitely from Kroger, because that's the logo they used to have. That's funny, because Krogers aren't everywhere, but they used a picture of a Kroger bag on here. Not in your book, though. I don't really know what that is. No, I think that's Kroger, too. That's the old logo. How funny. I never noticed that until today. Sorry. That was interesting to me. Okay, so let's move on to example 2. Okay, so now put your finger or pencil on example 2. In this problem, we're going to be doing something very similar to the first problem, but we're adding some numbers in. So before, we were just figuring out, is it ounces or is it pounds? Well, now we're going to do the same thing. We're just adding numbers. Is it a certain number of ounces, pounds, or maybe even tons? So finger or pencil on example 2. Read in your head while I read out loud. Which is the most reasonable estimate for the weight of a leaf? 1 ounce, 1 pound, 1 ton, or 10 tons? So first we're going to compare the weight of a leaf to the weight of objects that you know. So imagine a leaf, or you can go outside real quick and grab a leaf and hold it in your hand, or imagine holding it in your hand. Now let's think of things that we know weigh 1 ounce, 1 pound, or 1 ton, or 10 tons. So that leaf that you either imaginarily have in your hand or you actually have in your hand, is it about the same as 1 piece of bread or 1 strawberry? Are they equal? Is it about the weight of 1 loaf of bread or 1 pineapple? Is it the weight of 1 elephant or 1 car, 1 small car? Or is it the same as the weight of 10 elephants or 10 small cars? Well, obviously, when we think about it, a leaf is small and it is very light. So it's definitely not going to be the same as 10 cars or elephants. It's not even going to be the same as 1 car or elephant. It's really not even the same as 1 loaf of bread or 1 pineapple, which means we have 1 ounce less. Objects that weigh less than 1 pound are weighed in ounces, so the only option that contains ounces is 1 ounce. So a leaf weighs about 1 ounce. And if you imagine it, it really does weigh probably a little less than a strawberry or a slice of bread, but the closest we have to that has ounces is 1 ounce. So we would say about 1 ounce. So these are the types of problems you're going to have today. Let's move on to the guided practice where we are going to be doing this again with multiple choice. We actually had multiple choice here. We just didn't fill any bubbles. Well, now for numbers 1 through 3, we are going to fill in some bubbles. Okay, so now we're looking at the guided practice, which the directions say choose the best estimate for the weight of each object. So we're doing the same thing that we did in example 2, where they're giving us units and numbers, and we're choosing which one is best. Remember, we're thinking of the actual object, not just the picture. So, number 1, a paper airplane. Does it weigh the same as 4 strawberries or 4 slices of bread? Does it weigh the same as 40 strawberries or 40 slices of bread? Does it weigh the same as 4 loaves of bread or 4 pineapples? Or does it weigh the same as 4 elephants or 4 small cars? Well, if we imagine holding a paper airplane, or maybe you can make one and hold it, it's not very heavy. So we probably wouldn't measure it in tons. We definitely wouldn't measure it in tons or even pounds. And then we have 2 options for ounces, but 40 ounces, if we imagine 40 strawberries in our hand, well, that's probably going to weigh more than just 1 pineapple or 1 loaf of bread, especially if we imagine 40 slices of bread. Well, there are less than 40 slices of bread in a loaf. So that means that would automatically weigh more than 1 pound. So 4 ounces is the best estimate. Okay, number 2, we have a helicopter. In your book, it's a different picture, but I think they're trying to be clear that it is an actual helicopter, not a toy helicopter. Because in the textbook, we could think of that as a toy helicopter, or a model of a helicopter, but we're thinking of an actual helicopter. So, an actual helicopter that we might see flying in the air, maybe it's an emergency helicopter, or maybe it's a news helicopter. Does it weigh the same as 5 strawberries or 5 slices of bread? Does it weigh the same as 500 slices of bread or strawberries? Does it weigh the same as about 5 elephants or 5 cars? Or does it weigh the same as 500 elephants or 5 cars? Well, okay, so we know that a helicopter is much bigger than a car, even an SUV. It's bigger than any cars. So we know it can't be ounces, because a car, a small car, is 1 ton. A helicopter is bigger than a car. So that means it has to be tons. Now, a helicopter is bigger than a car, but it's not as big as 500 cars. So 5 tons is the best answer. Now number 3, a rabbit. Is a rabbit, a full-grown rabbit, not a baby rabbit, but a full-grown rabbit, is it about the same as 4 strawberries or 4 slices of bread? Is it the same as 4 loaves of bread or 4 pineapples? Is it the same as 40 pineapples or 40 loaves of bread? Or is it the same as 4 cars or 4 elephants? Well, we know it's definitely not going to be as big as 4 elephants. It's really not even going to be as big as 40 pineapples, because think about it. Most small children that are about maybe 2nd or 3rd grade, maybe even 1st grade, weigh about 40 pounds. And a rabbit is definitely not as large as a small child. Maybe younger than that too. I might be off on I'm not good at visualizing measurements, but this is helping. So a small child weighs about 40 pounds. A rabbit is definitely lighter than a small child. So 4 ounces or 4 pounds. Well, a rabbit is probably a little bit smaller, a little bit lighter than maybe a cat. So So 4 ounces would probably be too light. Maybe a baby bunny might be 4 ounces, but not a full-grown bunny. So 4 pounds would be the best estimate. Now let's look at this talk math. Does an object that is small always weigh less than an object that is large? Explain. So I want you to think about that for a second before we come up with the answer. So think about it. Does an object that is small always weigh less than an object that is larger? Think about it. Well, let's say I have a marble and then I have a balloon, a blown up balloon. Well, that marble is really small, but it's definitely heavier than a blown up balloon. A blown up balloon I can very easily hold and I can pop it up into the air and it floats. Whereas a marble, if I throw it up in the air, it's going to go right down because it is a lot heavier. So just because an object is small does not mean that it's very, very light. Just like an object that is large does not mean it's very, very heavy. Okay, so now we're not going to do any of the independent practice together because I think we've gotten enough here. But let's look at it. Numbers 4 through 9 are exactly like numbers 1 through 3 on the guided practice. Number 10 and 11 are just like the examples, example 1 and 2. Numbers 12 through 14, you are just using your reasoning skills along with estimating and choosing the best unit. So just make sure that you fully answer the question and make sure that you do include units, numbers and units. Numbers 15 and 16 are critical thinking and reasoning. So you need to think of what's happening and think about what you know and what you've learned today and put it together to come up with a new answer. Now let's look at the homework. On the homework, numbers 1 through 4 are just like examples guided practice 1 through 3. Numbers 5 through 9 are just like the examples, but you just have to match the object to the correct estimated weight. Numbers 10 and 11 are just like the word problems in the independent practice where you are reasoning. Make sure that you fully answer the question. Make sure that you have numbers and units if needed. Numbers 12 and 13 are vocabulary, so you're using what you know about weight and ounces and pounds, those words, and tons to come up with the correct answer. And then number 14 is just like numbers 1 through 4 on the homework, just without a picture. So go ahead and get started with the independent practice and then go ahead and do the homework, or you can wait till later this afternoon. If you have any questions about today's lesson, please reach out to me between 1 and 5 today. Remember, do not turn in this anchor chart with your work. That means you will have, you won't turn anything from this packet in you do have things to turn in today, but you won't turn anything with this packet in. You'll tear this off. You can do whatever you want with the cover page, and then keep the anchor chart for your own use. Okay, that's it. Reach out to me later today if you have any questions.